So thus far we've talked about how a new population can move into a region, how it can be dispersed. Now we're going to talk about what controls how many organisms are present in a given volume of space. And that's going to be termed population density. It's the number of individuals per unit area or volume. This is a map of the Earth, go figure. You'll notice that some areas have a lower density than others. For example, India is very, very highly dense. There are lots of people per unit volume. The United States, not so much. Maybe in the cities, yes, but just across the whole country, not as much as other countries. Europe, very, very dense. Some of the Caribbean countries are very dense. So individual per unit volume. That population density is constantly changing. Some areas are getting immigrants, new people coming in. Other people are experiencing emigration, people leaving the area. Just in Virginia, we're seeing changes in population. Here's the changes since 2010. You'll notice that in a lot of areas, these blue areas, you get population declines. People are leaving there like crazy. Leaving a lot of Western Virginia and Southern Virginia, moving more toward the areas like, up there's Northern Virginia, you've got our area, we're what, right over here, right? Do you guys know what our county looks like? We're a little bit more left. A lot of people think we're a little bit more left. Bluish? I'm pretty sure we're this one rightish over here. I might be mistaken. I know that we're one of the fast-growing ones. Man, hold on. I'm going to hit pause on recording this as we figure out where we live. Now that we know that we are, in fact, that red region right over here that's got rapid population growth, is that terribly surprising? You got to look around. What have you noticed around here recently? What's been happening as you drive from place to place? Do you see new houses? New developments? All over the place? New apartments? New apartments. Look, think about apartments versus houses, right? As far as population density goes. In a house, how many people can you fit? Roughly. 5, 10, whatever. Yeah. In one unit, you can fit 5 people. In an apartment complex in that same space, you can fit 10 times that many. So you're increasing the population density. Now, I'll tell you, one reason I moved to this area was because of the population growth. I used to live right here, down here in Danville, Virginia. You'll notice it's in this blue area. What does that mean? People are going away. So for a college professor who relies on having students in class, that's an issue. The population's declining, class sizes were shrinking and shrinking and shrinking, much faster than here. I thought, if I move up north to an area of rapid population growth, there's not going to be nearly as many problems dealing with the lack of students. Turns out population's declining here too now. It's changed. Here's where more people are coming in, but we're not getting students. There's a lot of reasons for that. Why might, in your minds, people, the population of students be declining? Competition, sure, competition among colleges for students. Think about it this way too, though. How many, for you guys, roughly, how many aunts and uncles would you have? Do you have? 0. A few. How many siblings do you have? 1, maybe 2. You'll notice that the past generations typically had more offspring than our generation. All right, so if there were 4 before and now you're down to 2, I'll talk just about my family. My family, my personal family. I have 2 siblings, 2 sisters. My parents, my dad had 3 siblings, my mom had 5. Now we narrowed it down to 3, all right? Of those the 3 siblings, we have a grand total of 2 offspring between us. We're dropping and dropping population size through just lower birth rates. And that's that's a national trend. So how do you grow a population? You get more births. Or you have more immigration. More people coming in through either being created or who are coming in from other populations. Flip side is, how do you shrink a population? Lower birth rate or a higher death rate. If your death rate outpaces your birth rate, you're going to have populations in decline. In those blue areas of the state that we saw, typically you have an older population. Lots of retirees. They're going to die at a higher rate than people who are younger. So you can grow a population through immigration or birth. You can shrink a population through death or emigration, people leaving. So once you've got this population, then you figure out how this population disperses itself. Where do these people live in relationship to each other, or these organisms live in relationship to each other? And you'll see a lot of different patterns in nature. You're going to see clumping, you're going to see a random distribution, and you're going to see territoriality. Clumping is probably the most common dispersion pattern. You're going to see a lot of organisms in one space, and then a big open area, a lot of organisms in another space. Humans tend to clump. Where do we clump? Cities, right? Basically, you have a whole bunch of people who can interbreed with each other hanging out in one spot. I will tell you that my friends who are on dating apps really prefer to live in the city than out in the country, because the pickings are pretty slim out there. Just not many people around. You see this across the board. Clumping can lead to a few positive things for these individuals. One, it puts you right next to a mate. It's easier to find a mate and continue with the population, continue growth. Oftentimes it leads to mutual defense and sharing of resources as well. So clumping is very common. If you were to look at trees, oftentimes among trees you're going to see a clump of trees of one type, then a space, and then another clump of trees of that same type. You might see territoriality, in which case these organisms are pretty evenly distributed. Oftentimes you see territoriality among predator species, lone predator species. Coyote packs, what you'll see is between one pack coyote and another, there will be an even distance. Sharks tend not to clump into big schools except to mate. So this is when they're actively inhibiting each other. Large trees, oak trees, are going to systematically poison the soil around them to stop other oaks from germinating. You're not going to see two oak trees right next to each other. Where one oak tree's root system ends, another can begin. And then you had a sort of a random distribution. You don't see that terribly often. Usually you see territoriality or you see clumping. Okay? So we model population growth or increases or decreases over generations. You don't just look at it right now. You need to see trends over time. And you're going to model these using either exponential growth, which is sort of this asymptotic one here, where you get sort of very, very slow growth at the beginning and then it just takes off. Or you get logistic growth. Logistic growth is going to have slow growth, quick rise, and then it levels out. What might cause a population to level out? Why would it become stable at some point? Why wouldn't it keep growing forever and ever and ever and ever? Yes? It reaches capacity. There's not enough resources. Most, in fact, I would venture to say all organisms will eventually reach that logistic stage because there's just not an infinite amount of resources. That's sort of like the whole thing Thanos was saying. An example of exponential growth would be like a feral cat colony. You start off with 2 cats. Those 2 cats are able to produce, let's just say, conservatively 4 baby cats. Those 4 baby cats then produce 16. Then, oh shoot, now I'm just doubling. 4, then 16, then 64, then 256, and we're not even out of the first year yet. 256 is what, 1028 after that? Thousands of cats by the year 3. Very, very quick growth. Tell you a story. The last college I worked at, we had a feral cat colony outside. One of the professors kept feeding the cats. I hated these cats. They kept coming to the door asking to be let in, everything like that. So he'd bring food out for the 2 cats that were there. Shortly thereafter, those 2 cats had more cats. So he brought more food. Now, the next season, there were even more cats. So he kept bringing more food. He was bringing in like a big old bag of food every day for these cats. Then he retired. Nobody else brought the cats food. And suddenly the cats start disappearing. They're just gone. Could be a few reasons. Why might those cats have started to disappear? No food, so they'll die of starvation. Why else? The other one would be predation, because as much as we hate to think about it, cats, dogs, they still have their own predators. Hawks, owls, and such. Exponential growth will keep going as long as you have abundant resources. As long as you have lots of food, as long as you have oxygen. But when you run out of space, when you run out of food, you reach what's known as the carrying capacity. At that point, there's more organisms than the population can support, so you start to see die-offs. Basically, you have lots and lots of growth, it hits a peak, at which point there's not enough resources for everybody, and they fight for resources. Only a few survive. So the population declines. But there might be some more resources present, so it goes up, and it sort of does this wave pattern until the whole thing levels out. That level right there at the top, that's the carrying capacity. That's how many organisms this population can support, this environment can support. Most, and again, I'd venture to say all organisms have a carrying capacity they reach with the population, with the environment. One example of this would be fish tanks. If you have a fish tank at home, you can only put so many fish in it. If you have a 10-gallon tank, you should probably have no more than like 3 to 5 fish in it because it's not enough space. Fish tanks very quickly run out of oxygen if there's too many fish. What happens if there's too many fish in a fish tank and they consume all the oxygen? What begins to happen? They suffocate and die, unless they're those snakehead fish. They suffocate and die. As they die, the need for oxygen decreases. So the oxygen in the tank begins to stabilize. Feed them too much, if you only feed a certain amount of food, there's going to be a certain amount of competition for that food. The amount of food that you put into the system, the amount of oxygen that's in the system, and the amount of space present is what's going to determine how many fish you can keep alive in this system at any given point. So as a population reaches its carrying capacity, the population growth becomes 0. There's no new people coming in, there's no new people coming out, it stabilizes. There's no more growth. So that is population density, the number of organisms per unit volume. And the number of organisms per unit volume is going to determine, and the energetic resources in that environment are going to determine how many organisms can survive there at any given time. You can have new organisms coming in through immigration or birth. You can have the population declining through either the death rate or through emigration, leaving.